Hey guys, welcome back to solving first order linear differential equations using integrating factors. So in my last video I went over first order differential equations, first order linear differential equations, and integrating factors. I went over the theory and the basics and just introducing those topics. So if you want to go and watch that video before doing this example, I would recommend you do that so you can fully understand what exactly I'm doing here. Otherwise, I'd like to start and do this example as soon as possible. So let's do that. So in my last video, if you recall, I wrote out the steps for solving these types of equations, and I'm going to just pull that up right here. So the first step is to check if the given equation is in standard form. Second, you find the integrating factor using the p of t from the standard form. Third is to multiply both sides by the integrating factor. 4 is to integrate both sides. And 5 is to finally solve for y. So let's do the first step. I'm just going to write that down here. Actually, let's use black. So check for standard form. Sorry about my handwriting. So if we go back to the problem, we see that our equation is ty prime plus 2y equals t squared minus t plus 1. And if we recall what standard form is y prime plus p of t, y equals g of t. And we can clearly see that this equation is not the standard form because we have a t in the front of our y prime. So we can go ahead and try to put this in standard form. And the easy way to do that is just to divide everything by t. So we can just go ahead and do that. So we're left with, if you just divide everything by t, you get y prime plus 2t to the negative 1, y equals t minus 1 plus t to the negative 1. So that is now in standard form, and we can continue on to the next step, which is find the integrating factor. Find I of t, which is our notation for integrating factor. So we find I of t using p of t, if you recall in the last video. So we could just look at our standard form and see that our p of t is this thing right here. So we know that our p of t is 2t to the negative 1. And now we just solve our I of t. So we know I of t equals e to the integral of p of t, which is 2t to the negative 1 dt. We can just solve that down here, which is equal to e to the 1 over t dt. And we know from basic calculus that the integral of 1 over t is ln t, and this simplifies to, since the e and the ln of t cancel and give us t, and the 2 stays up there, we get t squared. So this is our integrating factor, and with this integrating factor we could do our step 3, which is to multiply both sides of the equation. So let's do that. So I'm just gonna copy this down here. Okay, so I've copied the equation down here, and we're just going to multiply both sides by our integrating factor, t squared. Okay, so let's multiply this, and we end up with t squared y prime plus 2ty equals t cubed minus t squared plus t. Just want to make sure everything is correct. Yep, so this is our new function that we want to integrate both sides with. So we integrate both sides, and this will help us get, isolate that y that we're trying to solve for. So let's just take this, gotta keep on copying this down. Yeah, just copying. And we integrate both sides, so we do our integration notation, dt and dt, and now we integrate. Okay, so let's first integrate the left-hand side. So we could just go ahead and integrate this thing like a normal integration, but the interesting and cool thing about integrating factors is that the left-hand side, which equals, which is always going to be this, the integrating factor times y prime plus p of t. This is what this equals if you just backtrack, and this is exactly what we did here. So this equals this. This right here is always going to equal the integrating factor times y, and that's just always the case for these types of problems. So I could go into the proof of this and explain why this is true, but I think that would be for another video because I just want to focus on solving a problem using these steps. So we're just going to leave it at that. So because we know this, we can easily see that the left-hand side will equal the integrating factor times y, and our integrating factor is t squared, and y is just y. So now that we've solved the left-hand side, we should go ahead and solve the right-hand side. And the right-hand side is much easier to do because it's just basic integration. So the integral of t cubed is 1/4 t to the 4, and the integral of t squared is 1/3 t cubed, and the integral of just t is, you know what that is, 1/2 t squared, and don't forget your c. So that is integrating both sides. And now we can solve for y and get our general solution. So to do that, we're going to take this equation that we just got here and isolate our y, and that will give us our solution. So I'm going to go down here, copy our equation that we got in step 4. So we got a t squared y equals 1/4 t to the 4 minus 1/3 t cubed plus 1/2 t squared, and don't forget the plus c. So now to isolate our y, we can just divide everything by t squared. So dividing everything by t squared. And now that we've done that, we can just go ahead and simplify. So our left-hand side will just become a y because the t squares cancel, and the t squared and the t to the 4 will simplify to a t squared, so we get 1/4 t squared, and the squared and the cube will cancel, and we'll be left with a t, so we have minus 1/3 t. And our next term, the t squares cancel out, and we're just left with 1/2, and our last term is plus c t to the negative 2. So this right here is our general solution to our first order linear differential equation using integrating factors.